Hey Rock Buds, it's Rock Papa. Hope you guys are doing fantastic. Today we're going to talk about the Eastern Foreland Basin and in particular the Alleghanian Orogeny, the Alleghanian mountain building event. We'll look at how the Alleghanian Orogeny was different from both the Taconian and the Akkadian Orogenies. We'll look at how Africa finally crashed into ancient North America in a very unique way, where it shed its sediments and where it didn't shed its sediments. We'll look at some of those sediments and talk about the sequence and why they're what they are and where they are. So if you like this video and it's interesting to you, please subscribe, and thank you a million to all you most excellent and wonderful subscribers. I think about you all the time with great appreciation. So here we go. The Eastern Foreland Basin, the Alleghanian Orogeny. Let's set the stage for the Alleghanian Orogeny by looking at the east coast of ancient North America as it existed right before Africa crashed. And just to clarify, Africa crashed during the Alleghanian Orogeny. In this funky drawing, the red banana thing represents all of the terrains or pieces of real estate that were attached to ancient North America during the Taconian and Akkadian orogenies. And here comes Africa getting ready to crash. Hey guys, one of the ways that the Alleghanian orogeny was different from the other two is that it was not so much a subduction and volcanic mountain chain event as it was a crashing, one continent crashing into and riding up on another. Nevertheless, huge mountains were produced by that crashing in the same way that the Himalaya mountains are being produced as the Indian subcontinent crashes into the mainland over there, just shoving everything before it up into a super high mountain range. Same thing happened in the Alleghanian. Africa had a pretty unique way of crashing. The black arrow points to the very first place that the ancient African continent hit the ancient North American continent. First kablam of Africa hit at the very southern tip of New York, maybe about where New York City is right now. And when I look at the Rock D map of that area, very southern New York and Pennsylvania, you can see that the whole valley and ridge is punched in toward the west right there. And my take is that this punched in area happened when the ancient Africa first made contact. After Africa hit at that southern New York, Pennsylvania point, it began to rotate clockwise. This is significant because it means that the effects of the Alleghanian orogeny did not occur from most of New York and northeastward. In other words, no mountains up there and no sediments deposited. That's why we have a lot of granite plutons up there, like the Cadillac Mountain in the Acadia National Park, that were never metamorphosed into granite gneiss. As Africa swung around clockwise, it created huge mountains that began to erode, depositing massive amounts of sediments into a foreland basin that it had created as it rode up on the ancient North America. The foreland basin that all these sediments were deposited into was not very deep because it had just been filled up by the Catskill Delta of the Akkadian orogeny. It had a layer of limestone that had been deposited in between the two orogenies. Since this foreland basin was not deep, there was no black shell deposited, only a huge amount of mud, silt, and primarily sand coming down from these mountains. The first place these sediments that were eroded off the huge Alleghanian mountains were laid down was adjacent to where it first hit. That would be the area of Pennsylvania, West Virginia, and probably Ohio. And so an intricate network of rivers draining this area developed pretty quickly in the history of the Alleghanian orogeny. Hey rock buds, and at the same time that this was happening, glaciers were coming and going, and that meant that the sea level would rise up and then the sea level would go down based on the status of these glaciers. And this glaciation on and off went on throughout the entire Alleghanian orogeny, and geologists call this fluctuation in glaciation, they call it cyclotherms. So in these early days of the Alleghanian, you got this massive coastal plain area developing on top of these sediments, the extensive fern forest developing along the river courses. Hey rock buds, another change from the Akkadian and Taconian orogenies is that during the Alleghanian orogeny, eastern United States was in the tropics, and that facilitated the growth of these massive fern forests. Extensive fern forests would form on this coastal plain and along these coastal plain rivers, and then the glaciers would form. Sea level would go down. That would increase the erosional gradient, and sandy sediments from the eroding Alleghanian mountains would come down and cover these fern forests up, giving rise eventually to our present day coal. Since the fern forests were covered by erosion sediments from these eroding rivers from the Alleghanian mountains, this coal did not contain high sulfur content, as did later coals that were formed when the ocean rose and covered the fern forests. So we got a lot of high quality, low sulfur coal forming in these areas. Okay, fast forward a few million years, Africa's continuing to rotate clockwise. More sandy deposition increasing the coastal plain, but what's really significant here is the rotation of Africa was like a vice, severely squeezing the area that is now our Valley and Ridge province, especially up in the area of Pennsylvania, West Virginia, Kentucky. The squeezing process metamorphosed the coal beds that were in this area, turning them into anthracite coal, which is a very high quality coal. It is more dense than the bituminous coal that we find on the Cumberland Plateau, and it has a higher BTU content. In addition to that, much of it is low sulfur coal, so that's a really great area for coal mining today. The little yellow dots on this map represent the areas of high quality anthracite coal. Eventually, the river system draining all these mountains increased to an Amazon-sized river system. The outlet of this massive river system with all its material came out around Alabama and Mississippi and created what we now call today the Black Warrior Basin. This Black Warrior Basin area was a huge coastal plain with braided rivers in it that led into a Mississippi River-sized delta, and there were also barrier islands created by all the sand. Eventually, this ginormous eroding coastal plain spread out west, northwest, and southwest, all the way at least to where the Mississippi River is now, although since then a lot of that has been eroded away. So the Illinois Basin is topped off with all this Pennsylvanian and Permian sandstone. The Michigan Basin is also topped off with it. The Appalachian Basin is topped off with it, and also the Black Warrior Basin. Very extensive. Hey, rock bud, you notice the little red spot there? You may recall that it represents all of the terrains that were added to the eastern edge of the continent during the rifting of Orogeny, the Taconian orogeny, and the Akkadian orogeny. All this material in one big package was shoved over to the west at least 200 miles. This huge package of rocks was slid along a major thrust fault that ended up locating it present day about the eastern edge of the Valley and Ridge province. And this thrust fault has a lot of different names. In Georgia, it's called the Cartersville Fault. In North Carolina, Tennessee, it's called the Great Smoky Fault, but it's all the same fault. Hey guys, the Alleghanian and Orogeny also produce massive coal beds on today's Cumberland or Allegheny Plateau. But that is all bituminous coal because Africa did not push and shove the area that's now the Cumberland or Allegheny Plateau enough to metamorphose that bituminous coal into anthracite coal. Another little tidbit is that as this bituminous coal was formed, and especially the coal that was formed in the later stages, was formed when the fern forests were overwhelmed by the ocean as the glaciers melted. Ocean has sulfur in it, and so a lot of that coal got sulfur imparted to it by the ocean, which reduced its quality. But there's a lot of it. This picture shows a generalized stratigraphy of the deposits of the Alleghanian orogeny, with the Greenbrier limestone being the first deposit and the Dunkard group, mostly sandstone, being the final deposits. Here's a flooded quarry in the Greenbrier limestone, and this was deposited during the late Mississippian, and as a matter of fact, this layer of limestone covered the entire country, not just the eastern United States. It has a lot of different names. If you go out west, you will find it being called the Madison limestone. I won't show you pictures of all these formations. You've probably seen enough of them in the other videos that I've done. But some interesting points. The Mall Chunk formation is mostly red beds, and it marks the time when we were just in the edge of the hot, dry trade wind belt, just fixing to get into the tropics. The Pottsville Sandstone is a pretty massive formation, and it was laid down when we first got into the tropics, though it has no coal deposits in it. Coal forests came later and are represented by the Allegheny coal, the Conemaugh coal, and the Monongahela coal. And finally, the Dunkard group is mostly sandstone, but there's no coal associated with it. Okay, Rock Buds, that's it for the Eastern Foreland Basin, the Alleghanian orogeny. Thank you so much for watching. Thanks so much for hanging in here with me on this. And hopefully it was useful to you, if so please subscribe. And this here is your Rock Papa saying happy rock hunting to all you fantastic rock buds. Papa out.